On this episode of Far Out, a NASA center known for pushing the boundaries of flight is now pioneering sailing in space.
So light actually pushes it.
And building robots that can creep and crawl around the moon. Whoa! You think you know NASA? Well, think again. I'm Megan Cruz. Come with me to experience the extraordinary, the unexpected. This is Far Out. Trivia time. There are NASA centers across the country. Can you name which opened first? Here's a hint. It's in Virginia, and an award-winning film featured some of its hidden heroes who helped get us to the moon. If you guessed NASA's Langley Research Center, you are correct. And way back in 1917, just a few years after the Wright brothers' historic flight at Kitty Hawk, Langley opened as the nation's first civilian facility focused on advancing human aviation. But nowadays, Langley isn't limited to aeronautical research. People here do all sorts of cool stuff, like Jim Nealon, who's designing and building soft robots. Let's see if we can chat with him. Jim.
Hey, Megan.
Oh, hey, Jim. Did you want me to come down, or are you coming up?
Grab a hard hat and come on down.
Okay.
It's one small step for man, one giant leap for mankind.
Megan, welcome to the surface of the moon.
I appreciate it. It was so easy. I just went down a ladder.
We do it every day.
Because this here is why Jim and his team are making soft robots. NASA wants to learn how to live and work on the moon as a stepping stone to Mars.
So traditional robots that we design are designed with a specific task in mind. When we go further and stay longer out in the solar system, we need systems that will be able to adapt to an unknown environment and be able to maintain and operate within that environment.
Okay.
Soft robots give us that ability to do that. They can form around strange unknown objects and be able to manipulate them or move around them a lot better than a traditional robot would be able to.
And because soft robots, made mostly silicone, are soft.
If there are astronauts around these robots and they come in contact with the astronaut or the spacesuit, there's no damage there, so they're safe for people to operate around.
I want to see these soft robots in action. So we leave the moon and head to...
Our lab space is right over here.
Okay.
These are all the different types of soft robots we are currently looking at for possible use in space. We have a chainmail like this embedded in the silicon, right?
Yeah.
And you can see in one orientation, it's very easy to roll around.
Okay.
And the other, it locks and can take pressure or force.
This kind of reminds me of that claw you see in the carnival game where you're trying to pick up a stuffed animal.
Absolutely. But those claws are very rigid and they're not
Right.
specifically designed to pick up all of the objects that are in those games.
Yeah.
So a soft robot, however, is very compliant and able to bend around the shape naturally and provide a better grasp.
So this is kind of how we were talking about there might be some benefits to using soft robots versus traditional hard robots.
That's correct. We can take an object like this, a pair of glasses, and if you want to hold
Okay.
that right there,
Uh-huh.
hold it from the top,
Okay.
and I'll apply the air pressure.
Oh, whoa. So because this is soft, like what does it allow this to do better?
It moves in, it can move into the different areas of the object that you're picking up and provide more surface contact for a better grasp.
Okay. I wish we had a stuffed animal to like actually test your theory, this analogy that we put.
I can help you.
Okay, we do. We have a stuffed animal. Whoa! Look at all the stuffed animals I could have won in all those years, all the money I wasted. What does this one do?
Oh, this is a very interesting new project that we're looking at that's been biologically inspired from the octopus. One of the hard things about building large structures in space is being able to outfit them with power, data, cryogenic lines. A robot like that, controlled like an octopus arm, could very easily go through the structure and place specific cables or data lines in certain areas that a traditional robot would find very challenging to reach. This is very early development. We're just learning the science behind how those octopus tentacles operate.
Learning not just from Mother Nature, but also other soft robots already in use here on Earth. As they say, necessity is the mother of invention.
There's a number of areas right now where soft robots are being used. Search and rescue is one of them, where these soft, pliable robots can get underneath rubble and go search for survivors. Marine biologists use them to collect delicate deep-sea creatures. Also in physical therapy, where it's helping folks regain the use of their muscles and limbs after an accident or an injury. That versatility kind of guides us to the designs that we are looking to have them used in space.
Are soft robotics, is this just a very new field in general?
Soft robots actually has been around for quite a long time.
Since the 1950s, actually, but possibly using them in space, that is very new, thanks to recent advancements in material sciences. By now, you get why soft robots would be an asset for us on the moon. So, do you want to make one with us? We're gonna make this gripper.
In this particular one, which is a gripper, we've actually embedded other fibers in it so that we can do a specific in-space assembly task.
There you go.
And then this is our silicone. So we mix the silicone as a two-part silicone that we'll mix